will this one be uploaded?
This one, right after.
Okay, so it's gonna be okay, great. Thank you, Jesus. Thank you so much.
You're welcome. I also did want to mention one like little housekeeping thing. So I know on Friday I said I would upload a bunch of stuff this weekend, but so what had happened was this weekend was very weird, and I basically had no time to do anything, and I completely lost my voice all day yesterday, so I couldn't record anything for you guys, which kind of sucked. But now I'm back. I'm good. So I'm going to finish recording all the stuff I promised you guys on Friday, and that'll be up either by the end of today or tomorrow morning for sure, because I want you guys to have time to study it before the exam. So if you had any questions about that, hopefully I answered it. Also, I sent you guys 2 emails today because I said I attached a bunch of stuff and then I completely forgot. So I sent you guys an exam review handout. So that is different from the handouts that we've been using, and it covers everything that we're going to cover during the exam review. And I wrote out, I'll actually show it to you guys since I have it up. I wrote out everything like this, so if you have it open and you choose to write on it, it'll save you a lot of time, and it'll save me a lot of time during the review because then I won't have to like write everything out, like stuff like this I drew, so you guys don't have to sit here and watch me like duplicate and struggle. So yeah, this should be in your email. It would be really helpful if you have it for the review. Without any further ado, any questions before we get started? Cool. Okay. Also, I just want everyone to know that I am currently wearing spooky socks and a spooky boa, but you guys aren't in person, so you can't see it, and that makes me very sad, but that's okay. So right now, we are about to cover one of my favorite things because it looks really ugly and complicated, but it's actually super easy, and if you do the rosemary method, you will be golden. So in case anyone is confused, because I know we've been jumping around, this is back at the end of chapter 12. It's like the putting it all together section at the end. And there's these 2, but I wrote on them. So we're going to do these first and then go back to those and I'll clear it. So I'll give you guys a second. And actually, while you guys pull that up or do whatever you're doing, I'll go ahead and do that. Delete. Okay. That's how you can tell I was filming something in the middle of the night, because then I forgot to erase it. Alrighty, so this is great because it's a 5-step question, which means that it'll be 5 separate questions in one. And that's really actually good for you guys because of the time crunch. So if you've never seen this kind of question before, it'll be really difficult to like figure. Anyway, whatever. I'm trying to. So many words, not enough space to get them out. If you've never seen this before, it'll take a while to like figure out what's going on and do like 5 questions at once. But if you're able to practice with these multi-step things and figure out the logic, it'll be really, really quick. And then someone was asking in the chat, where is this? This is at the end of the chapter 12 handout. It's on the last page. I think it's chapter 12. Yes, chapter 12. So the first thing you are going to do, step 1 always, is figure out what reactions are taking place. And you need the most simple, bare minimum idea, right? So going from an alcohol to a ketone is what kind of... wow, people already answered me. It is an oxidation, exactly. And the reason it is an oxidation is because we have 1 bond to oxygen, 2 bonds to oxygen. And then there were a couple questions in the chat. I'll just go back to that once I'm done with this because my attention span is not the best. So now we went from a ketone to an alcohol, but we're not going to call this a reduction. It's a different reaction. Can anyone tell me which it is? Please. One person did, but I want at least like 1 or 2 more people. Cool. Okay, so it is the Grignard reaction. And the reason we know it's the Grignard is because we added a methyl. The only reaction we've learned about so far that adds a carbon group is the Grignard. And I'm just going to write Grig because I don't want to write the whole thing out. So the next step, we go from an alcohol to a double bond. What word can we use to describe that? We could definitely use elimination. Yes, we could also use, someone said dehydration. Exactly. Sweet. And then what happens in the next step is I just took this product and I put it as the starting material for the next line. He may just do it where he goes from here and draws the arrow to the next one, but I didn't want to confuse you guys, so I just started off fresh. So when we go from a double bond to an epoxide, if we make an epoxide, we're going to call it a epoxidation. But specifically, a lot of people said it in the chat, we have to use a peroxy acid. And the reason we know that is because we only learned 2 methods of making an epoxide. One of them included an alkyl halide and an alkoxide, excuse me. And the other one involved a double bond and a peroxy acid. And so now we go from an epoxide to an open area. So we know that there has to be a cleavage or a breaking of an epoxide. And that's all we need to do for the first step, right? Now we are going to look at the answer choices because you can get a lot of really quick and easy hints, I guess. So A has Mg. Immediately, what does Mg tell us? What reaction are we doing? Grignard. Exactly. And then we have O7. What is the 4 or more oxygens rule? Yes, it's an oxidation, but specifically, like someone said, that means it's a strong oxidizing reagent. Exactly. Okay, so what about O3? What does O3 tell us? Peroxy acid. Cool. And so remember, 4 or more oxygens means it's a strong oxidizing agent. Exactly 3 oxygens means peroxy acid. And so the next one is just an acid catalyst. This one is just H2O and some acid, and this one is a base. So I'll just write acid and base for now. And also let me go ahead and 1, 2, 3, 4, 5. So immediately, without looking at anything else, we know that the answer to 1 is what? Cool, everyone said B, and that is correct because that's the only oxidizing agent. Cool. And then for number 2, what would the answer be? A, awesome. And the reason for that is because that's the only Grignard reagent. So the dehydration, what do you guys think it could be? D, awesome. And the reason is because one of the reactions we learned about were acid catalyzed dehydration. And in this case, there was no like rearrangements or anything. So you don't really have to worry about any of that stuff. We know that 4 would be what? You guys told me earlier. Absolutely, it would be C, and that is because we know this reaction had to happen with the peroxy acid. And so now we've used up A, B, C, D, and we have an acid and a base, right? And either of those are possible for cleaving an epoxide, right? So we actually have to pay more attention. This carbon is what? Primary, secondary, or tertiary? Tertiary. And then someone asked something about the last one. So how do you know that 3 is D and not E? That's a good question. They are both acids, but H2SO4 is a much stronger acid, and that's the one that's going to be more likely to do a dehydration. And that's the one that we kind of learned about earlier. So yeah, that's the best explanation I have. And then someone asked, okay, someone asked about the summary and said that they need, sorry, it keeps disappearing. Oh, apparently oxidation was not on Dr. West's summary, but reduction was. And yes, I saw that. And someone said, so should you still study oxidation? I mean, don't spend like 5 hours just studying oxidation, but know the concept and know the general summary that we went over, because like these things build up on one another, and just because it's not on the summary doesn't mean the concept can't pop up. And this is like an example of that. So I say, yeah, still know it, but don't spend like all your time studying. And so, okay, as you guys said, this carbon is tertiary. What about this one? Secondary. Sweet. All right. And so we also know, in terms of stereochemistry, the side that was attacked will flip stereochemistry, and the side that was not attacked will stay the same. So we know that this side had to be attacked and open this way because the secondary carbon was the one that kept its stereochemistry, right? And so which prefers tertiary to secondary, acid or base? Acid. Okay, so remind me what the order for acid catalyzed cleavage is. 3, 1, 2, exactly, because it's a pain in the ass. So what about our basic bitch? 1, 2, 3. Awesome. So yes, I mean, we pretty much just explained it, but you guys tell me, would the answer be E or F? E, perfect. So that is the rosemary method trademark, and I hope you guys find it useful and that you use it for the exam. I'm really sad that I can't watch you guys take the exam and like proctor, because I love walking around and seeing people like write exactly the steps that I did. It's so cute. But anywhoomst, I'll leave this up for a second and I'll scroll back because I saw a couple questions, but they all disappeared. And then if you have any questions, feel free to either unmute or say them in the chat or whatever you would like.
I have a quick question.
Yes, go for it.
So for the third part of the synthesis, the dehydration, if we were to say that we were hydrating instead of dehydrating, like if we could flip it, then we would use E, right? We would use a weaker acid that is diluted in order to hydrate. Okay.
Exactly. So if you were going this way, you mean like from the double bond to the alcohol?
Yes.
Yes, you're absolutely right.
Thank you.
You're welcome. Okay. You guys are doing amazing. I did get a lot of participation, so I'm super, super happy. And so now we're going to scroll back up to page 5, I think, of the chapter 12 handout, and we're going to do these problems. Again, these are the ones that look complicated. but they're not too bad once you know how to do them. So I believe that you guys could do these all by yourselves, but I am lazy and I don't want to put you into breakout rooms, so we're just going to do it together. I would like you guys to answer my questions, pretty please. So step 1 is PBR3. What does PBR3 do? Yeah, it's a protecting group. This is true. What else? Oh, yes, SN2. So it flips stereochemistry. Exactly. What else do you guys remember? Forms a good leaving group, retains... Whoa, where'd it go? Yeah, it helps protect the alcohol. Cool. But the biggest thing I'm looking for is it goes from an OH to what?
An alkyl halide.
Exactly. So a bromine in this case. Perfect. So I'm going to draw it like that. So our OH is replaced with a bromine. And so at this point we have A. Right? And then in the next step, what does magnesium do? Immediately, magnesium, every time we see it, what do we think? Grignard, exactly, because it's the home wrecker, remember? So the Grignard comes in, or excuse me, the magnesium comes in, it breaks apart the bromine carbon bond, right? So what charge is left on the ring? And someone said it's the sugar baby. Exactly. So what charge do we have left on this carbon? Negative. Cool. So that means if it has a negative charge, it's going to be a really strong what or a what? Nucleophile or base. Yay. Okay, cool. So at this point, we now have a carbonyl. And for bonus points in my heart, not in the class, what is this thing called? Also, while you tell me that, this is so ugly, I can't. I have to redraw it. It is a cyclic ester. Exactly. Perfect. And it's also called a lactone. So now, let's get rid of this MGBR because we don't care about their stanky relationship. All we care about is our negative charge. So it's going to come in and bam, attack that carbon. Electrons go up. And I'm going to do this in like the quick kind of way. If anyone needs me to go through and do it in the full steps, let me know. But we know that the electrons would then come back down and kick open the ring because we would get rid of the leaving group, right? And so we number the chain 1, 2, 3, 4. So let's get a 4 carbon chain. We reform the double bond. And we have this carbon group, right? That was the Grignard reagent. On carbon 1, 2, 3, 4. Or I guess I numbered it 1, so my bad. So I guess it'd be 1, 2, 3, 4. We have our oxygen, and we know that that gets protonated.
Wait, I'm sorry. Why did you skip one carbon on the when you were numbering the ring? It's 1, 2, 3.
Sorry. As soon as you said it, I looked at it and I realized I made a mistake. Thank you.
Oh, gotcha.
This is why I tell you it's so important to count your carbons, because I don't. So 1, 2, 3, 4, 5. Yes, you're right. So 1, 2, 3, 4, 5. And so here is our OH. Thank you very much for bringing that to my attention. So then at this point, are we done with the reaction? Ooh, we got a 50-50 split. We do have water. Water is right here, so that's still in the reaction. And that's what protonated our O-. But since our Grignard reagent is a super, super, super strong nucleophile, what can it do? Yes, so a couple people said it. Since we reform this double bond, it's going to attack again. But this time we don't have a leaving group, so we will not reform the double bond. Instead, we are going to make an alcohol, and we added 2 carbon chains. And I'm kind of running out of room, so I'm sorry that it looks kind of wonky, but I hope you guys get the gist. So, what kind of alcohol did we form here? Primary, secondary, or tertiary? Primary, perfect. So, what about this one? Tertiary, awesome. Cool. Any questions, comments, or concerns?
Okay, so for when you went to the from the bromine to the carbon anion, how did that really happen? Did the bromine just leave?
Oh, okay, I see what you're saying. Sorry. So what happens is the magnesium essentially comes in here and breaks this bond. And so it's kind of hard to explain because it does some really weird orbital stuff, but essentially it comes in and it steals the bromine. And so on the side you have MgBr, and the Mg has a plus charge, and the carbon and the bromine will have minus charges. So they're kind of all being held together, but it's not a real bond. They're just kind of attracted to one another. But the carbon is such a good nucleophile that if it sees anything it can react with, it'll leave this group and it'll go do the reaction.
Okay, and then then the ether comes in, and that's why you put it on the ring now, because it attached to. Okay.
Exactly. Yep. And then someone said, "How did you know that it would react again?" And essentially, for the Grignard reaction, as long as you reform the double bond, it will react again. So if you have a leaving group such as this one, it will react 2 times. And then someone said, is this a form of reduction? Yes, because it's not the same as what we did before, but yes, it is a reduction because you're reducing this right here. And before I do the next one, I forgot to send the attendance link, so I'm sending that to you guys now. And also, this is itchy, so I'm going to take it off. And I'll give you guys a couple seconds. If you have any questions, let me know. If not, we will start the next one.
I have a question.
Yes. What's up?
So the answer should never have a double bond in it because it's always going to be attacked.
Pretty much, yes. So I don't want to say never have a double bond in general, but you're never going to have a carbonyl.
Okay.
It will be attacked.
Okay, so how come I'm gonna say in like step 1, 2, 3, in like step 3, why does that double bond get reformed like once it's broken? Is it because of the leaving group?
Yes. So exactly. We know that sp2 is more stable than sp3. So since we have the leaving group, reforming the double bond would make it more stable. So then it could kick off the leaving group. If that makes sense.
Yeah. So if that leaving group wasn't there, then like it would have just been broken and then we would have had our answer kind of thing.
Exactly. Cool. I love when you guys make connections and you like, what is it called? Like the no carbonyl thing you said. Like I love when you guys do that and you guys make connections. It's really, really good for the rest of the semester because it's essentially the same thing and you just gotta see those patterns. So proud of you guys. Okay. Going to the next one. So we see MGBR. So what does that tell us? Grignard, exactly. But does anyone know what my trick question is going to be before I even ask it? Yes, there is an acidic hydrogen because this hydrogen right here is on a triple bond. That's one of the super acidic ones that we talked about. So we have our CH3 minus, which is our Grignard, right? And I'm not going to ask because you guys already said it in the chat. So it's going to grab this hydrogen and give those electrons to the double bond. So we are getting this. And why do we usually call that no reaction? Ooh. Yes, someone said it exactly perfectly because it's not the Grignard reaction. So this is just acid-base chemistry. And if we didn't have any of these steps afterwards, this would just be an equilibrium and we would consider it no reaction. But since we have another reactant, by the way, this is I forgot to write that in. We are reacting with an epoxide. So I decided to make it more difficult for you guys and I added like this extra group, but Dr. West said not to bother because it made people confused and he's just going to stick to the regular epoxide. So we're just going to stick to the regular epoxide. If the epoxide is drawn like this, do you have any preference for which side we're going to attack? No. Cool. If we had substituents, then we would get into what the preference is, but we're not going to worry about it here. We attack, open it up, and remember, make sure you add 2 carbons. And so coming off of our triple bond, we're attached to carbon 1, and then carbon 2, and then carbon 2 is attached to an O minus, right? And
I'm sorry, you said if we have substituents, what?
I'm so sorry, what did you ask?
Oh, I'm sorry, you said if we have substituents, what do we do?
Oh, so if the epoxide had substituents, then we would have to figure out which side we're attacking based on like acid or base. But since there were no substituents, we didn't have to worry about that. Both sides were exactly the same. Did that make more sense? Okay. Cool. All right. So at this point, we have B. And when we add H2O, what is going to happen? Protonation. Cool. So I'm not going to redraw all of that. Sorry. Ta-da! So what kind of alcohol is this again? Please remind me. Primary, secondary, or tertiary? Primary! Awesome. You guys are killing it. So any questions about this one so far? Or not even so far. We finished this one. So this is C. It's our final answer. Any questions about this one?
Can you explain again why the MGBR doesn't do anything in this case?
Yes. So in this case, since we already had the Grignard reagent formed, all we're going to do is get rid of this and react with this. And the reason for that is this is what our... Sorry, writing and speaking at the same time is kind of hard. So this is what the Grignard reagent looks like, right? And the reason I drew this bond in pink, unlike these ones, is because this is a really, really weak bond. It's not even really a bond. They're just kind of attracted to one another, right? But once the Grignard reagent, which is only this that we're going to consider, sees something else to react to, this kind of just dissociates and goes off on its own. It's almost like, I forget the chemistry word for it, but like, you know when you have OH minus and then they put a K in front of it? Spectator ion. It's almost like a spectator ion.
Oh, okay.
And how do you know when there's an acidic hydrogen there?
Good question. So an acidic hydrogen in a Grignard reaction is a triple bond, carboxylic acid, or on a heteroatom. And I can write that in the corner. And then someone in the chat had asked, why is the triple bond still there? And that is because we're not like touching the triple bond at all. All we're doing is giving it extra electrons and then getting rid of those electrons. So we're not changing the number of pi bonds that it would have. Since we're
So for like the last question, the previous one, like the double bond was like removed, and for this one, why isn't like the double bond removed?
Good question. So the reason is because we don't want to think of this as a double bond. I mean, it is a double bond, but it is specifically to an oxygen versus this is between two carbons. So when it's between a carbon and an oxygen, our Grignard is going to attack, and that's going to be our electrophilic center. However, here, if it's between two carbons, it's not going to want to react as much. And
I'm sorry, I just had...
No, go ahead.
Oh, sorry, no. Well, I just wanted to say about that last question. Can you identify where the B product is so I can just follow in order?
Oh, yes. So let me just write that. I love when I start and I forget. So this would be A, this would be B.
Oh, okay.
And this would be our final product, C.
So B is okay.
And to make it look clear, I'll just do this.
Okay, and then you add that to B. Oh, okay, and then we get that. Oh, okay, great. Okay.
So you said like for the last one, you said it's between two carbons, so it wouldn't react or anything. Like the double bond would just stay there.
Exactly, and the other part of it too is because when we think about it, the reason this is so reactive is because it has that delta plus, right? And it's acting like an electrophile, but this here would have a really big electron density. So instead of acting like an electrophile, it would most likely want to act like a nucleophile if it had to react. Plus, we gave it this extra set of electrons, right? So it's no longer happy and peaceful as a triple bond. It now wants to act like a nucleophile. But once it's done that reaction, it doesn't really, it's stable again. It doesn't really want to react. Whereas this one, was to an electronegative atom. It has that delta plus, and it would be pretty electrophilic. Is that a better explanation?
Yes, thank you.
You're welcome.
So I kind of just want to build on what Travis was asking. You know, if we were to introduce our final product to another like Grignard reagent, it would just strip that acidic proton, right? So it would just take that away, and then it would be final product from there.
Yes. But okay, so one thing I do want to say is, so in this example, right, I left this OH alone and I still did the Grignard reaction. And
Right.
the only reason I did it like that is because usually when I draw it out, I leave this unprotonated and then I attack and then I protonate at the end. But I just realized that it is probably confusing if I do it the other way around. So I'm just going to go ahead and change it. Like, so everybody know if there was a hydrogen, yes, as you said, it would attack that instead. So how that relates to what you were originally asking in this question is if you had more of the Grignard reagent, it would only react with this since it's already protonated.
And I had a follow-up. You were talking about that last one with the two benzyl groups or the two phenyl groups. Is it possible that that primary alcohol on the end of the carbon skeleton could act as an electrophile and just sort of like pop off that carbon? Do you see what I'm saying? But could it just use its electron pair to attack that carbon and then like form a you know what I'm talking about? I ran out of words.
So one thing first, I know what you meant, but just for like exam clarity purposes, this isn't technically a benzyl or a phenyl. It's just a cyclohexane. Okay. Because there's no double bonds. But like I knew what you were saying. What you were asking, it makes sense because yes, we know that this is a little bit electrophilic because this could essentially pop off. The only reason I say it wouldn't happen is because in comparison, like if you compare this carbon to this one, it's much, much more electrophilic in the carbonyl case. So if the nucleophile had to choose like either this or this to attack, it would always attack the carbonyl. But then if you were saying like we added more Grignard at this step, could this come off? The reason it's no is because of this acidic hydrogen. But let's say you put a different nucleophile in there. Theoretically, yes, we could. But not with the Grignard reagent. Does that make sense? Or did I kind of sound...
It makes sense. I'm just trying to put the pieces together.
Just one more thing, just for clarification purposes, can you just go through the detailed steps from product B to the lactose? How did it go from B to the lactose molecule?
So, great question. It didn't. That's why I removed the arrow. That was completely my bad. It was very misleading. The lactone was the reactant that was reacting with this, so I meant to do it on top of the arrow. That's why I erased it and I did the plus. So instead, what's happening is not that it's turning into this, but it's going to attack the lactone and it's going to break it open. And then once it breaks it open, we turned this ring into this linear structure, and then we just added this group to it. Did that
So basically the product B, then we just add the lactone to when we have product B, we add the lactone. So the product B attacks the lactone and it forms what we have there.
Exactly.
The green. Okay. So we're adding the cyclic ester.
Precisely. Yep.
Oh, okay. Gotcha.
Also, I love so much that you guys are using your mics and you even turned on your cameras at some point. It makes me so, so happy. So, just wanted to let you know. Okay, so we have a couple minutes left. So, I don't want to start a new topic or anything. So, we can either just do a little summary of chapter 12 in the next couple minutes, or you guys can ask me questions if you have any specific questions.
I have a question.
Yes.
So, like, for this test, like, what would you say the level of difficulty would be? Like, since you've already taken this class, and like, what do you think we should study on? Like, 11 and 12 more than 13, or?
Okay, so great question. In my experience, when I took the class and when I have like SI'd for it before, the exam was not the worst. So when I took the class, I'm not going to lie to you, I was not a good student for the second exam, so I literally didn't even know what was on it. I just kind of went in and took it. But that being said, without knowing anything, I still got a C+. So that should give you some hope, right? But then once I actually learned the material and I reviewed my exam, it was like completely fair. He doesn't really try to trick you. It's pretty straightforward. That being said, I know it's a little bit weird now that it's online and there's that time thing. When I took it, it was still 32 questions in 50 minutes, but the biggest difference is that it was on paper. So it like there was no room for technical difficulties and we could flip back and forth. And I know it's really different for you guys. So that time is an issue. I have a feeling he's never going to respond to my email at this point because he emails me about other things and pretends that email never happened. So I will try again. But he hasn't like given me any input thus far. So I don't know what's going to happen with the timing thing. But Katrina and I have both been bugging him for that.
Honestly, if it was like 32 questions in like 50 minutes, then I think that the questions, should be really like straightforward, and they should be like quick. They shouldn't be like complicated.
Yeah.
You know what I mean?
I totally agree. And the difference, like the first exam is always a lot worse than the rest of them, even when we are in person, because it takes a lot of time to do those problems. So yeah, everyone always hates the timing on exam 1, so it sucks, and I know. But for these ones, these kind of questions aren't as bad, in my opinion. They are more straightforward, and each one of them takes less work, in my opinion, because you're not sitting there like counting signals and matching NMR spectra and like looking at exact like reaction mechanisms from Orgo 1, right? There's none of that kind of stuff. So
for this one, he might like on the test, for example, like he might say like, "What is B?" or something, and it would be like E's right there with the dots.
Yes, exactly. More likely than not, though, he'll just ask you for C. But yeah, read the question because once in a while he will be like, "Oh, what's A?" And you're like, "That's a pointless question, but okay." You know.
And then you still get it wrong anyway.
Yeah. It's one of those things where Dr. West's perspective is that, like, he doesn't have to do much to trick people, which is really mean. But, like, in Orgo 1, they make every answer choice, like, almost exactly the same, and you have to, like, whip out your magnifying glass and, like, figure out what the difference is, right? But Dr. West is just like, they're expecting me to ask for C, so if I ask for A, everyone will get it wrong, and then there you go. So it's one of those things where I'm like, it's not that it's the worst exam in the world, it's just you have to kind of be paying attention and like read things thoroughly. And
yeah, that's the same thing for like Jermaine too.
Yeah. What was I
So is Dr. West going to have like stacked reactions like you do in the SI handouts? Like, is he going to give us a starting substrate and then be like, okay, it goes through A, B, C, D, you know, and then what's the final product?
So
Is that going to be
we'll give you guys more like questions that are structured the way his will be. But he will definitely have a few questions that look like this and like this. I'm 99% sure he will have this, right?
Okay.
But then for the most part, it'll be things like this, like which of the following won't form Grignard. He might ask you a couple things where he just gives you this much and you have to give the final product. Like this, where he'll just give you starting material and final product and you have to give the reagent. So for the most part, it's stuff like that. There's not too many like stacked reactions, but it does happen. Another thing is know the reactivity of carbonyls, because he will for sure give you at least one question that's like, rank these in the order of most to least reactive or least to most reactive.
Okay.
And then
I just had a question.
Sorry, 1 second. I was just going to say that someone had asked a similar question in the chat, asking if there will be a lot of the ones that we just did. So I hope that answered it. If not, I can give you a better answer. So yes, what was your question?
So I just had a question about the last reaction that we did. It is an acidic hydrogen, so it will not react. But because there is an epoxide in it, it will form. Is that what you said?
So pretty much yes. When we say no reaction, we mean no Grignard reaction, right? So there will always be this acid-base stuff. But as you said, since there's an epoxide, excuse me, there's something else to react with. So now we can consider it a reaction because it'll undergo multiple steps.
Okay, all right, I got that. Another thing, what on chapter 11 do you think we should study for? Because that's a little, I didn't really get that chapter so much, so I just want to make sure exactly what like to look for in that chapter.
Yes, that's totally fair. Okay, so start with Williamson Ether, right? Just know that the conjugate base of an alcohol is the alkoxide. Alkoxide plus alkyl halide gives you the ether. The intramolecular Williamson ether synthesis will give you an epoxide, but it can also give you any other kind of cyclic ether. And then just know that an acid catalyst is going to be 312, and ethers can only be cleaved in acid. They're stable in base, besides epoxides. So epoxides are super unstable, so they can be cleaved in acid or base. Just know how to name crown ethers. So remember, the bigger number goes first, and then the smaller number. The bigger number is how many members there are in the ring. The smaller number is how many oxygens there are. A quick way to do it is count the number of oxygens and multiply by 3, and that will give you the bigger number. Know this reaction, because wink, wink, nudge, nudge, it always pops up. So know the difference between when it's just HBr versus when they give you excess. And then...
Sorry, and excess means reacting twice.
Exactly.
Right.
So then peroxides, just know that it's 3 oxygens, and that gives us epoxides. Or sorry, I think I said that wrong. Peroxy acids, just know that they are 3 oxygens, and they form epoxides from a double bond. And yeah, we already covered this. Remember, bases are basic bitches, so it goes 1, 2, 3. Acids are a pain in the ass, so it goes 3, 1, 2. And then also remember that this is an SN2-like reaction. So whenever we attack with the nucleophile, wherever we attack, we'll flip the stereochemistry. And yeah, I think that's pretty much it for chapter 11. Oh yeah, just also know that you're going to keep your configuration, so cis will end up cis, trans will end up trans. I know it's still a lot, but does this kind of help you guys a little bit?
Yes, absolutely. And I was gonna ask you a favor. Well, I don't know if you can keep these questions that we just asked on your recording that you're gonna post on YouTube, so that we, in case because I wasn't able to write down everything that on chapter 11. So if you could just, so I know what to study for in chapter 11, and if you keep it on the YouTube recording, then it'll be great. I can go back to it and see what you said.
Cool. Yeah, the only time because sometimes I do get rid of the questions at the end, and the only reason I do that is like if someone asked a personal question or something like that. But I will definitely keep this in there because it was really helpful. Cool. So that's pretty much all I have for you guys. I'm willing to stay for a little bit and answer any more questions if you have any. If not, happy Monday. Enjoy the rest of your day. I'll see you tomorrow or Wednesday.
I have a question.
Yes. What's up?
So the exam is 2 hours, right?
Mm-hmm.
So the first hour is it gonna all be questions, or is some gonna be like actually reviewing the material? It's how's that gonna go?
So, okay, good question. The first hour is just gonna be like start to finish concept review. So we're gonna start with chapter 11, and we're gonna go all the way through to the end, and we're going to give you guys like the main points, the big ideas, the fun facts to remember, all the summaries, tips and tricks, that kind of stuff. And then the second hour is going to be, I'm going to cover a couple questions that I think are really important for you guys to do, like the short version of, like kind of what I showed you just now, the long multi-step equations. And then once we do that, we are going to have that 32 question Kahoot game, which will be kind of like a practice exam, but it should only really take like 40 minutes, not the full 50, because, we kind of give shorter questions, if that makes sense. And then we should have like 15 minutes at the end to go back and answer any questions that anyone has, or to review any concepts that maybe people weren't sure about.
Okay, thank you.
You're welcome.
I have a question. So I wasn't here for the Friday session.
Mm-hmm.
Did you guys, by any chance, finish the chapter 13 SI sheet?
So let me actually go and look, because I don't remember where we ended. Okay, so we went into the Diels Alder, but we didn't go into page 7 or finish page 8. We're going to do that on Wednesday.
Okay, thank you.
If you want, I can leave this open if you want to take a picture or whatever.
All right, thank you. I appreciate it. I was going to go through the video anyways when you post it today.
Cool, okay. And then someone asked, on the summary, Dr. West put epoxide from halohydrins. So the halohydrin is the Williamson Ether, yes. And the reason it's called a halohydrin is because it's a halogen and an OH on the same molecule.
And just to verify, the questions for tomorrow, you're also going to leave, right? Like when you guys do the review for the exam, you're going to leave their questions also?
So,
not personal questions,
Yeah. Exam reviews are a lot different than regular sessions. There won't be as much participation just because there's usually a lot more people and we're trying to get through a lot of stuff. So even though I won't be asking you guys what is a lone pair, or what is an electron withdrawing group, we leave a lot of time for you guys to ask lots of questions. So we will for sure record all of those sessions and keep and keep them in there. I talk way too much. You guys asked the simplest question, and I'm like, well, let's start from day one, back at the beginning. But yeah.
Okay, I have a question, but it's more like I just kind of need some advice. The extra credit practice exam is what it says is due tomorrow, but I'm literally way too scared to even open it because if it's anything like the last test, like I know I'm just gonna do terrible on it. But I really want the extra credit points. So like, do you have any sort of advice at all as to what I should do?
Yes. Okay. So, as someone who had really terrible anxiety and would literally ignore half my assignments because I was scared to open them, first step is try to like take a minute, breathe, and remind yourself that you know things a lot more than you think you do. Like half of the reason I structure my sessions the way I do is because I know that you guys know so much, but you're so scared that you kind of like negate what you know, right? And also, just a little thing, Karina was able to go into the extra credit, so she told me it didn't look too bad. It's pretty, she said it was pretty straightforward. There's a lot of naming, things like that. So hopefully it won't be anything too crazy. But, yeah, back to what I was saying. Take a deep breath, get a coffee or get some tea or whatever makes you feel good. Sit down, tell yourself, I can do this. Even if you don't believe it, tell yourself you can do it. You're going to do amazing. Be super nice to yourself for like a minute, 2 minutes, and then get into it. And it will make it will make a world of difference. And if you have a stress ball or whatever they call them, those can be really helpful too.
Okay, good to know. Thank you.
Okay, let me look in the chat really quick because someone asked a question like 10 minutes ago and I just completely... Someone said in the last question we did, is the Grignard cleaving the epoxides in basic conditions? Yes, so since it's a base, we can think about it in basic conditions. In the SI sheet for the intermolecular portion, I drew 2 epoxides. I don't know, let's open it up.
Another thing I wanted to ask, because I'm not really sure, I have not the greatest memory. Did we happen to finish chapter 13? Or
No, I did see your thing. I'm sorry, it took me a while. We did not finish it. We kind of jumped around a little bit, which I feel kind of bad about. We have a little bit left to do for Dealzalder, which we'll cover on Wednesday. But I wanted to get through this stuff before Wednesday so you guys had a chance to practice it. Okay, and to the person who was asking about this, I'm not really sure, but I brought it back up if you want to look at it and ask.
Yeah, so
Yes.
on the right side, you drew the cyclic ether with the wedges.
Mm-hmm.
And then right below it, you drew that. I'm not sure what it's supposed to mean.
So the only reason I did that is because usually I draw it this way, but people were confused because I think in Orgo 1 or something, it was drawn like this or in the textbook or something. So I just drew it both ways so you guys would see that they're the same thing. The only difference is here we kept the 2 substituents on like opposite planes and this was in the same plane versus here this is planar and we can actually see the stereochemistry. So this tends to make more sense, but yeah, that's why I drew both.
Okay, so they're the same thing.
They're the same thing, yeah, just 2 different ways to draw it.
Okay, thank you.
You're welcome. Okay, guys. So if there's no more questions, I will let you go. Bye! Also, thank you for the sea turtles. That made my day. It was great.